All right, guys, we got to talk about the hydrolysis of phosphoenolpyruvate. Pyruvate is, man, is that a big to do? All right. And so if we look at this on the slide here, phosphorylation, we have ADP plus this gives us ATP that requires energy. However, the hydrolysis of this phosphoenolpyruvate with water gives us pyruvate, which is very important, and the compound that's required up here, and that releases quite a bit of energy. All right, that releases 14.8 kilocalories. And so what we end up with here, what we get here is when ADP actually gets phosphorylated, we actually release quite a bit of energy. Um, and all this is are added up reactions. You can see up here, we have this with fructose. Fructose gives us fructose 6-phosphate in water, and that requires energy. This isn't crazy. And then ATP breaks it down. That releases energy. We get this. We could do the same thing here. Fructose, ATP becomes ATP. We get fructose 6-phosphate. Here we could talk about ATP swinging in there, and this becomes glucose 6-phosphate. That's just a shorthand way of doing it. So you're going to see a lot of this ATP swinging in. Creatine has been studied like hugely. Creatine phosphate's right here. When you get water, you get creatine in this phosphate, and that releases quite a bit of energy. And so creatine phosphate, you get ADP, and you generate ATP, you get creatine. There's more ATP. More ATP means more energy. And so when you start talking about people that take creatine, what they're doing is they're trying to generate more ATP, which is going to free up energy for their muscles. There's a couple different types of processes here. We get aerobic pathways, which need O2, and anaerobic pathways, which do not need O2. You guys have probably heard of this before. Uh, Slide 11. All right, we're going to get into our coenzymes right now. All right, NAD plus and NADH. We're going to draw them. Let me tell you right off the bat, we're going to call it NAD plus and NADH. You will not have to draw them again. I'm just showing you the structure so that you can see like why we're going to go about doing that. You have got to remember this, all right? Oxidation, we're losing electrons, or we're losing hydrogens, or we're gaining oxygens. That's oxidation, all right? There's three different things that could be going on here. Reduction is gain of electron, gain of hydrogen, or loss of oxygen, all right? If there's oxidation, there must be reduction. Like you can't just have one. An oxidizing agent causes something to be oxidized, therefore it is reduced. A reducing agent makes something be reduced, therefore it is oxidized. All right, here we go. If, see this, these are two big ifs right here. If this coenzyme, if it gains H plus or electrons, the coenzyme is reduced. Therefore, it's an oxidizing agent. If it loses H plus or electrons, the coenzyme is oxidized. That means it's a reducing agent. Okay, we gotta put that together. So here, NAD plus, that is going to gain an H. If it gains an H, that's an oxidizing. This right here, NAD plus, is an oxidizing agent. NADH is a reducing agent. Here are our pictures. This is NAD plus. This is NADH. You're not gonna have to draw them. You got it? Like, you're not gonna have to draw them. We are gonna use NAD plus and NADH, end of story. All right? And so here, what we can start talking about is I've drawn some examples here. We get, we want one CO bond there. We get NAD plus becomes NADH plus H plus, all right? And what we get here is you end up with two carbon-oxygen bonds, or we can think about it differently. So you have a oxygen right there, or excuse me, a hydrogen right there and a hydrogen right there. Both of those H's are gone. That means this compound has been oxidized because it lost hydrogen. Hopefully that makes sense. Because it lost hydrogen, it has been oxidized. Here are more, NAD plus, we're oxidizing this. Remember ethanol, we talked a lot about this when we start oxidizing alcohols, is the primary alcohol. We get an aldehyde. So we oxidize it. This is our oxidizing agent. Boom. That means this gets reduced. Here we got another one. I know I didn't draw it great, but we have pyruvate. This is a reducing agent, all right? Or it's going to add hydrogen. See, we have this carbon-oxygen double bond. When you add those H's, you get H and H here. Down here, we could talk about formaldehyde. What coenzyme are we going to use here? What coenzyme are we going to use here? This one, this one's going to be NADH plus H plus, because what are we doing? We're taking this ketone and we're making it an alcohol. Here, this is an alcohol, we're making it a ketone, or sorry, this is an aldehyde, sorry. So this is going to be oxidized.